Chapter 1, Lesson 5 is negative exponents. So we remember that our negative exponent rule says that if you have a negative exponent, you would move the number to the denominator and make the exponent positive. So we're moving this whole thing to the denominator. And when we move it to the bottom, there's nothing left on the top. So we have to put a 1 for place value to show that there's a number on the top, because you can't have just a fraction with something on the bottom. You have to have something on the top. So this is going to hold our place. It's a 1. Okay, and then also anything to the 0 power would give you 1. So if it is 5 to the 0 power, that would give you 1. If it's 200 to the 0 power, that would give you 1. Okay, these negative exponents, you're going to move it to the denominator, as you can see. And when you move it, it becomes positive. So that's the reason that we're moving it, because we don't, negative exponents are not proper. So we can't leave an expression with negative exponents. We have to change them to positive exponents. Okay, so all of these, same thing. These are already in the denominator. We want to make them negative exponents. So we would move them to the numerator. Now they're alone without a fraction, and make it negative. So here again, moved it up to the negative and make it negative. If it doesn't already have an exponent, we need to change it so that it does have an exponent. So we know our perfect squares, and we know that 36 is the same thing as 6 to the second power, or 6 squared. So we're going to change the 36 to 6 squared and make it a negative exponent by moving it to the top, or the numerator. Okay, so let's do the guided practice on this page. Number 1 on your guided practice says 2 to the negative 4th power. And the rules, or I'm sorry, the instructions say write each expression using a positive exponent. So we're changing these from negative exponents to positive exponents. All right, so number 1 says 2 to the negative 4th power. We don't want it to be negative, so we're going to move that to the denominator and make it positive. So 2 to the 4th power is on the denominator. And if we put 2 to the 4th power in the calculator, we would get 16. So this simplified would be 1 over 16. If they just want you to leave it as a positive exponent, your answer would be 1 over 2 to the 4th power. Same thing here, we're going to move it to the denominator and make it positive. So 1 over 4 to the 3rd power would be the same thing as 4 to the negative 3. And the same thing here. 4a to the negative 4 moves to the denominator, a 1 in the numerator, and we make it a to the 1 over a to the 4th power. And this one, 1 over g to the 7th power. Number 5, the instructions on 5, 6, and 7 say write each fraction as an expression using a negative exponent other than negative 1. So it's saying other than negative 1 because it doesn't want us to just move this up and make it 16 to the negative 1 power. We have to change this 16, for example, to 4 squared. Okay, so let's look at number 5. This one says 1 over 3 to the 4th power. Easy enough, we move it to the numerator, make it 3 to the negative 4th power. So these are inverses, so same thing here, okay? 1 over 5, m to the 5th power would become m to the negative 5th power. We move it to the numerator and make it a negative exponent. 16, again, we need to make this into a number that has a positive exponent. So 16, we remember, is the same thing as 4 times 4. So 4 squared would be our positive exponent number. And to make this a negative exponent, we would move it up and make it negative. So 4 to the negative 2 power would be our answer here. And then the same thing on this one. 49 is the same as 7 multiplied by 7. So 7 squared. Moving it up and making it negative would be 7 to the negative 2nd power. Number 9 says an American green tree frog tadpole is about 0.00001 kilometers in length when it hatches. Write this decimal as a power of 10. So we remember to write something as a power of 10, we would need to move the decimal over so that the whole number has a decimal right after it. So the decimal right now is here. We move it 1, 2, 3, 4, 5 times, and this is a very small number, and so my exponent would be a negative exponent. So this is 10 to the negative 5th power because I moved the decimal 5 times to the right. So if you move it to the right, it's negative. If you move it to the left, it would be positive. Okay, and then number 10, 11, and 12 just say simplify. So we're going to simplify these. You can change them to positive exponents first or after. I used my other exponent rules first to combine the ones with like bases. So I remember if they have like bases, I can add the exponents. Negative 3 plus negative 2 is negative 5. So 3 to the negative 5th power moves to the denominator to make it positive. So this is 1 over 3 to the 5th power, or if they want me to fully simplify, 3 to the 5th power in the calculator is 243. So this is also 1 over 243. And again, if it says simplify like these instructions, I would go ahead and put it in the calculator and get a number answer. So 1 over 243 would be your final answer here. But you could also write this. This one is the one that I think that they want when it says simplify completely. All right, here again, I added the 2 exponents because they are like bases to get r to the negative 4. Negative 7 plus 3 is negative 4. And then I moved this to the denominator to make it a positive exponent. So 1 over r to the 4th power would be my final answer here. On this one, though, I changed them to positive exponents first. So because this is negative and in the denominator, to make it positive, I moved it to the numerator. So p over 12. This one is negative in the numerator, so I would need to move it to the denominator to make it positive. So p to the positive 2 would be in the bottom. And then I remembered my rules that said if I'm dividing like bases, I can subtract the exponents. 12 minus 2 is 10. So p to the 10th power would be fully simplified in this problem. I could have subtracted first, and it would have given me the same thing, p to the 10th power. And so that's the end of lesson 5.